Hello, welcome to my YouTube channel. My name is Nenyi Abraham and I'm your mathematics teacher for today. Now, we have started this studies for the fourth time now. We are in our fourth lesson and we are on the topic set. And in our first lesson we learned about the identities of sets. And then in our second lesson we learned about simplifying sets, simplifications of sets. And in our third lesson we also learned about addition and subtraction of sets, the addition of set and subtraction of sets. Now in this lesson we shall learn about the rationalization of sets. But before we start with the rationalizing of sets, I would like to brief you on the conjugate of sets. Now, what are conjugates? A conjugate. Now we have monomial sets. A set. Now, if a set have only one term, I'm giving an expression of one term, which is a set, we call them monomial. For example, if you have root of a, it is a monomial set because it has only one term. But if you have root of a plus b, these are two terms. It's an expression of all two terms, and so this is not a monomial. It's not a monomial. They are two terms, and so it's a polynomial. It's not a monomial. So every set that is of one term is called a monomial. Now, the conjugate of a monomial set is the same set. If you have a root of a, then the conjugate of the root of a is still root of what? A. Now, if you have a set like this, root of a plus root of b, root of a plus b, then the conjugate of this set is root of a minus root of b. And so in simple terms, the conjugate of a set is changing the arithmetic sign in between the two terms of the set. Then you become of two terms of an expression containing set is what we term as the conjugate of that set. Now, for example, root of b plus c. Now, this is an expression that contains a set, root of what? B. Now, to find a conjugate of this set, all you need to do is that you change the arithmetic sign, which is the plus here, to minus, which is root of what? B minus c. Then this becomes the conjugate of this set. So when it is minus, you change it to plus. When it is plus, you change it to minus. So the conjugate of a set is changing the arithmetic sign of the set. The arithmetic sign in between the terms, or in between the two terms in an expression containing set. That is what we term as what? The conjugate of a set. Now, sets are just like fractions. So I don't want to say that. When sets are put in a form of fraction, just like fractions, if you have a fraction like 12 over 3, in the normal sense, this is a proper fraction. In the normal sense, we don't like putting fractions in improper, sorry, this is an improper fraction. We don't like putting fractions in an improper form. So you change it to proper, so mixed fraction, which will give us what? 4 whole number 4, sorry. So this is not a fraction. This is not a fraction. So let's say being given 12 over maybe 5. 12 over 5. This is an improper fraction. In normal terms, you don't leave it this way. You change it to a mixed fraction, which will give us what? 2 whole number 2 over what? 5. Now the same way when sets are being put in fraction, for example, a over root of what? B. A over root of b. You don't leave it this way. This makes it improper fraction, and so you change it to proper fraction. And how do we do that? The process of changing it into proper fraction is what we term as what? Rationalization of the set. So in short, one of the principles of set is that you do not put set as the denominator. So every set must be placed as the numerator. So the process of taking away, when being given a set or as an expression and it contains a set as the denominator, the process of what? Converting it into a proper fraction is what we term as what? Rationalization. And what do you do that? How do we do that? Sorry, how do we do that? How do we do that? That is what will bring us. So that we have what we term as what? Conjugate. So you multiply the numerator, both the numerator and the denominator, by the conjugate of the set that an expression contains. For example, a over root of b, it contains a set root of b. So you multiply both the numerator and the denominator by the conjugate of the set, which is root of b. The conjugate is root of what? B over root of what? B. And this is equal to a root what? B over root of b square. And this is equal to a over a root of b over b. And this is a proper fraction. This is the right way of writing a set or an expression containing what? Set. This can also be written this way, so don't get confused when you see them writing it this way. It's just a over b multiplied by this, and you know that whenever things are multiplying this way, it multiplies the numerator. It multiplies the numerator, not the denominator. Every number is over 1 or has a denominator of what? 1. Every whole number has a denominator of what? 1. So if given this a over root of b plus c, how do we simplify this? This is a set, but it also contains the set is in the denominator, so you change it to its right form. What is the conjugate of this set? The conjugate of this, the denominator, is by changing the arithmetic sign, which is addition here, so we change it to what? Subtraction. Multiply it by both the numerator and the denominator. So it will be a multiplied by root of b minus c divided by root of b plus c multiplied by root of b minus c. Now we all know about difference of two squares, and the numerator, these rules of difference of two squares holds in this set. So this will multiply this, which will get this, as we already know. But this is difference of two squares. When it happens this way, in difference of two squares, you square the negative term, the expression with the negative term, you square both terms there. So it will be root of what? B square minus c square, and the answer will be a root of b minus c all over b, because it is b, because this will cancel this, and minus c square. And this is the answer for that expression. This brings me to the end of this lesson. In the next lesson, we shall look at some of the examples, mathematical examples of rationalization. Please subscribe to my YouTube channel if you haven't. Thank you very much for watching my YouTube tutorials.